The future is flexible, printed and flexible electronics. Electronics are shrinking and becoming more flexible. We can now print circuits on bendable materials. This opens up amazing possibilities for new gadgets. Imagine phones that fold up or sensors woven into your clothes. This technology is called printed and flexible electronics. Flexible electronics can be used in many industries. Wearable health trackers and fitness devices are already popular. In medicine, flexible sensors can monitor patients comfortably. They can be integrated into bandages or clothing. Flexible displays are another exciting application. Imagine a screen that rolls up like a newspaper. These displays can be used in phones, TVs, and even electronic paper. The future of electronics is flexible, but there are challenges to overcome. A new challenge: heat in wearable devices. Traditional electronics use fans and heat sinks to stay cool. These bulky solutions don't work for small, flexible devices. Heat management is a major challenge. Wearable devices sit close to the skin. They must not get too hot for comfort or safety. Heat buildup can also damage sensitive components. Batteries, processors, and displays are all affected by high temperatures. Overheating can reduce their lifespan and performance. In extreme cases, it can even be dangerous. Staying comfortable, the human body and heat dissipation. The human body is very sensitive to temperature. Our skin has receptors that detect heat and cold. We feel uncomfortable when our skin temperature changes too much. For wearable devices to be successful, they must not cause discomfort. Our bodies already work hard to regulate temperature. We sweat to cool down and shiver to warm up. Wearable devices must work in harmony with our natural thermoregulation. They should not interfere with these processes. Designing for coolness thermal management in wearables. Thermal management is crucial when designing wearables. Engineers must consider heat dissipation from the start. The goal is to keep the device and the wearer comfortable. Several factors influence thermal design in wearables. The choice of materials is important. Some materials conduct heat better than others. Device size and shape also play a role. Smaller devices have less surface area for heat dissipation. Power consumption is a major factor. Devices that use a lot of power generate more heat. Section 5. Modeling the heat. Predicting temperature in wearables. Before building a wearable device, engineers use computer simulations. These simulations predict how heat will flow through the device. They can identify potential hotspots and test different designs. This process is called thermal modeling. Thermal modeling helps engineers optimize the device for thermal performance. They can experiment with different materials and layouts. This ensures the device stays cool during normal use. Modeling helps avoid costly redesigns later in the development process. Section 6. Materials matter. Choosing the right stuff for thermal control. The materials used in wearable devices impact thermal management. Some materials, like certain plastics, act as insulators. They trap heat close to the device. Other materials, like metals, are good conductors. They help dissipate heat away. Thermal interface materials, or TIMs, are important for transferring heat. They are placed between components that generate heat, like processors and heat sinks. Choosing the right TIM is crucial for efficient heat transfer. Section 7. Active cooling. Taking charge of temperature regulation. Some wearable devices use active cooling methods to regulate temperature. These methods involve using components to move heat away from the device. Fans, pumps, and thermoelectric coolers are examples of active cooling solutions. Active cooling is more effective than passive cooling but requires more energy. This can impact battery life. Engineers must balance cooling performance with energy consumption. Active cooling is often used in high-performance wearables. Section 8. Power management. Using less energy for cooler operation. Reducing power consumption is key to managing heat in wearables. Engineers optimize software and hardware to use less energy. This lowers heat generation and improves battery life. Power management techniques include using low-power components, optimizing software for efficiency, reducing screen brightness, and turning off features when not in use. Section 9. The future of cool innovation in flexible electronics thermal management. The field of thermal management for flexible electronics is constantly evolving. Researchers are developing new materials and techniques to improve heat dissipation. Nanomaterials, for example, show promise for their thermal properties. Other innovations include flexible and printable heat sinks, phase-change materials that absorb and release heat, and bio-inspired cooling solutions that mimic nature. As flexible and wearable electronics become more complex, thermal management will become even more critical. Innovative solutions will be needed to keep these devices cool, comfortable, and safe to use.